Hey students, I'm going to walk you through the selection sort. Remember, the basic premise of the selection sort is that each time we're going to go through the array and find a small value. First time through, we'll find the smallest value. In my example here, the smallest value of this array would be 6. If I'm going for ascending order from least to greatest, I would like that 6 to be at the very front position of the array. I could make a copy of this array or a separate array and put the 6 into the first index, but in an effort to save memory, what we'll do is we'll just work with the existing array. That's going to require me to actually take the number that's currently at index 0, 66, and swap places with that 6. So I'm going to write code that's going to go across the entire array and search for the minimum. And then once I've located it, I'm going to swap it with the number that's at the position that I want that number in to start, which the first time through will be index 0. So we've written lots of min index algorithms before, so hopefully this is comfortable for you. I'll just assume that the minimum's at index 0, and I'll write a loop that could walk across the remaining indexes of the array. So starting just to the right of 0 at index 1, I'll go to nums.length, and one number at a time. The basic question here is, if I go into the nums array at index I, am I able to find a smaller value than the number in the array at the min index, where I think the smallest number is? If I do, then I want to take min index and reset it to be I. Now, like I said, instead of returning this value, at this point, what I'm going to do is I'm going to look to swap it. So I'm going to take a swap to temporarily hold on to one of the two values, maybe num0. Okay. At that point, I could overwrite num0 with num's min index. And then I would then overwrite num's min index with the swap value. Okay, and that would complete our 3-line swap. Now, this is filling my array with random numbers, so every time I run it, I might get something a little bit different, but we should see the basic premise in the before and after. So in this example, well, this is a peculiar example because 18 was the smallest number, so no swap actually took place. Let's try another one. All right, so this time it looks like the smallest number in the array was 20, and I wanted 20 to take over index 0, which currently held a 92, and you can see that in my after array, the 20 and the 92 switched places. Okay, so that worked. I don't have a sorted array yet, but the process is the same. Okay, we would then want to repeat the process, but instead of looking at all 10 numbers of the array, we would look at the remaining 9. If I could scan through there, in this case, 23 would be the smallest number. It would then switch places with the 84. Okay, then I would look at the remaining 8 numbers, 7, 6, and so on. When you get down to only having one number left, there's really no reason to even consider it because there wouldn't be anything to swap it with. So at that point, we'd say that the array has already been sorted. So what we'll do is we'll enclose this process inside of its own loop. And this time I'm going to use J. I'm going to walk J across the array. The reason I started it at index 0 is, just like in my example, my first time through was using index 0. In fact, where I see these zeros, I'm going to change these to J's so that we can actually change where that min index is going each time. So the first time in, we're finding the smallest number of the array, and we're putting that all the way to the left at index 0. The second time we run this process, we're going to find the second smallest number of the remaining 9, and it will take over index 1 because J will have progressed to 1. Okay, third time up, J will have progressed to 2. We'll find the third smallest number. It will take over index 2. Okay, and so on and so on. Now, the one other thing we should change is right here, if I'm looking for, say, the fourth smallest number, and I assume that it's at index 3, which in that case would be J, then I would want to only search numbers to the right for a smaller value. If I allowed my loop to go to the left of that, I would, remember at this point, I'll have already put the 3 smallest numbers to the left. So I wouldn't want to consider any of those. So I'm going to start this inside loop at index J plus 1. That way I'm only looking to the right where I know that there's potentially larger numbers and hopefully maybe, I don't know, one smaller one. So let's see what happens if we try this. All right, looks like we have a completely sorted array from least to greatest. First time in the 1, then the 10, and so on and so on. With each pass of that outside loop, we picked up one of the minimum values, the absolute minimum, then the second smallest, then the third, and so on. It took 9 tries. Once we had the first 9 numbers arranged how we wanted them, then the 10th number had to fall into place. That's what allowed me to let that outside loop stop 1 shy of the end. Actually, oh, looks like I didn't do that. All right, but we'll try it on the second one, see if it still works. I'm going to add a print statement here so we can see for ourselves kind of like what's happening behind the scenes. All right, with the first pass of the loop, notice that the smallest number took over index 0, in this case 2. Okay, now when we did that, the 74 went to where the 2 was. This allows us to preserve memory. Instead of making like a brand new array and just putting in the numbers as I find them, by swapping within the array, I never had to actually create like a parallel array. Not a real big deal with 10 numbers, but if you had like a million pictures or some large file, it might be a big deal. Okay, second time the loop ran, we picked up the second smallest number. Third time, we picked up the third smallest, the fourth, and so on. If we come down here, there's 9 prints that you see here. There's 5, 6, 7, 8, 9. On the 9th pass, I got the 9th smallest number into place, in this case, 98. Now, if I know that those 9 numbers are arranged, then the 10th number has to be arranged also. That's what allows me to stop this loop 1 shy of 10. So I only had to actually repeat this process 9 times. The 10th one had to fall into place. If you wanted to see this go from greatest to least, okay, we could just turn around that inequality. There's other things we could do too. We could also change how the loops run. Instead of going from left to right, try experimenting with like a right to left loop so that you're sending the smallest numbers to the right as opposed to the left. There's a few variations you could try. If you see an array pop up where the same number appears twice, it's kind of weird, but like sometimes if there was say 2 7s in the original array, or in this case here, I have 2 1s. These 2 1s, I don't think it would have happened here, but there are cases where we could see, like if you think of the one on the left as 1A and the one on the right as 1B, they may have actually switched places with each other during this process. So we say that the selection sort is not stable. You can read more about that on your own. It's not really a big deal, but if you see that term being thrown around with sorting algorithms, stable or not stable, that's what they're referring to. All right, so that's the selection sort. Hope you're all doing well and staying safe. Let me know if you have any questions.